Hello all, my name is Khurram Arshad, and in previous video we have already seen how artificial neural network works. In this specific video we will see how we can create our own artificial neural network, how we can train ANN by the help of Python programming language. So for this let me share my computer screen with you. So we have already seen that how artificial neural network works. So to train our own artificial neural network, let me start with an example. Let's suppose we have input features x1 and x2. x1 is 1, x2 is again 1. I'm taking very simple example over here so you can easily understand how artificial neural networks work. So another record is 1 0, then 0 1, and the value of next value of x1 is 0 and other one is also 0. I'm going to perform OR operation x1 or x2. I am applying OR operation on these two variables. If you know about the OR operations, how it works, if both inputs are 1, then the result will be 1. If both inputs are different, result will be 1. If one input is 0, other is 1, the result will be 1. So if both inputs are 0, result will be 0. So OR operation works like as an addition in mathematics. So 1 plus 1 will take in computer 1. 1 plus 0 is equal to 1. 0 plus 1 equal to 1. And similarly 0 plus 0 is equal to 0. So for this data I'm going to train my neural network. I'll take two input neurons over here. These two neurons, let me take another color for this so you can view it easily. So I have two neurons, one neuron and second neuron. This is your input layer. This is your input layer, as we have two inputs over here na, x1 and x2. In this input layer we will pass x1 over to this neuron and x2 to this second neuron. x1 we will pass over here and x2 we will pass over here. Inside hidden layer I'm taking let's suppose 4 neurons inside the hidden layer. This x1 will be passed to this neuron as well as this neuron as well as third neuron of hidden neuron and hidden layer, and x1 is also passed to the fourth neuron of the hidden layer. After that we'll pass x2 to this neuron, then this, then this, then this. This will be the architecture of your artificial neural network. Then we'll get some kind of output. I'm getting only one neuron in the output. These values will be passed to this output neuron as well from here, and from here we will get some kind of output. This kind of architecture I'm going to implement today in this video. So how we will perform this? We'll pass x1 and x2 to the hidden layer, and then the hidden layer will have some kind of activation function, and we'll also get some kind of output from this output neuron. So in this example I'm importing a library named TensorFlow that is used to create the architecture for the neural network as TF, NumPy as NP. I'm going to execute it. So after executing this cell, here I'm passing my training data. Training data is nothing, same I'm using over here. You can see 1 1 1 0 0 1 and 0 0. I'm taking NumPy array, np dot arrays method. I'm preparing my input data set 1 1, then 1 0, then 0 1, and then 0 0. This is my X train or means training data. Similar, my output is 1, 1, 1 and 0. 1, 1, 1 and 0. This will be my output. So I have now my input data as well as my output data. Let me execute this cell as well. So this cell is successfully executed. Now next, let me clear these. Yeah. So you can see here in this cell, I'm creating my model's architecture. You can view over here. From TensorFlow, there is a wrapper named Keras. There is a module or class named sequential. This line of code, tf.keras.layer.dense, represents your hidden layer. Okay, so 4, I'm taking 4. I was telling you, in this architecture, I'm getting inside the hidden layer 4 neurons. So this thing I'm representing over here. So input, how many input variables I have? Only 2 variables. So that's why I'm showing input shape 2, 1. So activation function, I'm using ReLU over here. There are many activation functions are available: sigmoid, ReLU, eReLU, pReLU, leaky ReLU. So many activation functions can be used in this layer, in this hidden layer. So I'm using ReLU over here, and output layer I'm defining here. This is also called a dense layer, where I'm taking 1 as an output neuron and sigmoid as activation function. Sigmoid is the function that gives you the output in between 0 to 1. So I'm considering, if I get the output less than 0.5, then I will consider it as 0, or if I'll get the output greater than or less than 0.5, I'll be consider output as 0, and for greater than 0.5, I will be considering it as 1. So let's suppose if my output unit gives me output 0.3, I will consider it as 0, because it is less than 0.5. This kind of threshold I'm declaring over here, or I'm assuming over here. Similarly, if I get the output from the output neuron 0.75, so it is greater than 0.5, then I consider it as 1. So this is all about the architecture of the artificial neural network. So you can see I've already explained, and similar thing I have coded over here. So now I'm going to execute this cell. Before executing it, let me clear the screen. So when I execute, now model is prepared. After that, I'm compiling that model. For backward propagation, I'm writing all these kind of things. So I'm using as an optimizer Adam and loss function. I have already discussed there are many kind of loss functions. When I was discussing it in a very simple way, that if I am going to calculate the loss, so I was considering the formula y minus y hat. So there can be different loss functions that can be used in this position. So I'm using optimizer as Adam and binary cross entropy loss. So matrix is equal to accuracy. This will print the output of the model. So I'm also going to execute this cell, and now this is the line of code where your training will start. As I just execute it, you can see I'm getting the output. Loss is decreasing while training, and I have put this training for 1000 epochs. 1000 epochs. So this will take little time. One epoch, I have already told you, that is equal to 1 time forward propagation and 1 time backward propagation. this will become a single epoch. For the training this neural network, I have used 1000 epochs. As the training completed, I think it is already completed. So my model is trained. My model has been trained. Now I'm going to prepare my test data. In this step, I have prepared my test data for testing my model. So if you can see, I'll just predict. So model.predict is used for, model is my artificial neural network, .predict is the function to predict the test data. This is my test data. The same data I'm using inside, I'm using for the training. So 1110 01 00. So I'm using over here model.predict test data. So as I just execute this cell, you can see I'm getting the following output. Input is 1 then prediction, model has given me the prediction 1. So 1 plus 0 1. From this way you can train the artificial neural network. See you in the next video.